Hello, I'm Ryan Chan, CEO and founder of UpKeep, here to guide you through the fascinating world of electric motors. In this video, we're going to explore the types of motors, their key components, and how they contribute to the overall functioning of your machinery. You'll also learn how to effectively maintain these powerhouses to ensure smooth operations in your facility. As an added bonus, we'll also delve into some diagnostic tools that can help you nip potential issues in the bud. So let's get started. Let's talk about the power behind your machinery. Electric motors. These powerhouses convert electricity into useful work, and it's estimated that a whopping 70% of all electric energy used in the manufacturing sector in the US is consumed by motor systems. Given that most of the equipment used by a facility employs some type of electric motor, it's crucial to have a systematic plan for preventive maintenance. So let's dive into the world of motors and how to keep them running smoothly. Firstly, let's get to know the different types of motors. Electric motors can be divided based on the type of current that drives them: direct current, or DC, and alternating current, or AC. DC motors use the interaction of magnetic fields and a direct current supply. These motors are your go-to for more speed control and typically power variable speed applications like machine tools. But there's a catch. In a DC motor design, commutator assemblies supply an electric current but go through significant wear over time. On the other hand, we have AC motors. These motors also convert electrical energy to mechanical energy, but the supply is in the form of an alternating current. Their design allows the current to evade direct contact with commutator assemblies, making AC motors a more durable option. They have fewer deteriorating components, and due to their rugged and simpler construction, AC motors are more widely used in equipment. Now that we know the types of motors, let's talk about their key component. For a DC motor, you have three main parts: the field pole, which creates a steady magnetic field within the motor; the armature, which is the rotating component of the motor. When current passes through, it becomes an electromagnet and interacts with the surrounding magnetic field, causing it to rotate. Lastly, we have the commutator, the contact points that supply the current from the power source to the armature. It allows the direction of the current to be overturned to continuously drive the rotational motion. For an AC motor, the key components are the rotor, the outside part of the motor wrapped around with coils that transmit the alternating current, and the stator, the part of the motor that is coupled with the output shaft. Note that depending on the type of AC motor, the configuration of the coils on the rotor and the stator may take different forms and patterns. But like all machines, motors are not invincible. The moving components of motors can wear out after long durations of use. The rate of deterioration accelerates when certain components experience localized stress. Factors like voltage imbalances due to improper insulation, increased friction from lack of lubrication, thermal stresses, or even dirt and moisture accumulation all contribute to motor wear. To help you catch these issues early, there's some diagnostic equipment that can assist further than the usual preventive maintenance task. Infrared thermometers, for instance, can be used to assess temperature profiles. Ultrasonic analyzers can isolate distinct sound patterns around bearing, and vibration analysis is particularly great for rotating components. Finally, let's talk about preventive maintenance for motors. The U.S. Department of Energy provides a guide for maintaining assets such as electric motors. Having a checklist at hand helps to keep track of the types of motors usually found in a plant, as well as the components that you can expect each type to have. Along with a preventive maintenance checklist, the use of diagnostic equipment can provide targeted insights on implementing maintenance strategies for electric motors. So keep your motors running and your machinery working with regular preventive maintenance. And that wraps up our video on electric motors. We've covered the different types of motors, their key components, and the importance of preventive maintenance. We hope this information helps you keep your machinery running smoothly. If you found this video helpful, please give it a thumbs up and subscribe to our channel. For more resources, visit us at upkeep.com. Thank you for watching, and we'll see you in the next video.